Hello there, thanks for tuning to Excel Island and welcome to the channel. My name is Abatan Sheriffdeen, and on this channel, so far for the past 58 days, I've been trying to learn consistently every day and not to miss a day using the resources on the Datacamp platform to upskill myself as a freelance data analyst. So I'm a top rated plus freelance data analyst on the Upper platform. So I decided to learn for the next 100 days using the data analyst in SQL career track on the Datacamp platform. And I've been able to achieve that consistently for the past 58 days. So I'm on the career track data analyst in SQL career track. So the goal is to learn and upskill myself daily. So you can see data analyst in SQL 67% through the track, and the goal is to learn 30 minutes, 45 minutes to 1 hour consistently for the next 100 days. So I've been able to achieve that so far. So I'm still coming back after data analyst in SQL career track. I plan to start with data analyst in Power BI career track also. So this career tracks contains 11 courses. 11 courses, so I'm on the 8th course. So I'm starting chapter 3 of the course today. So without further ado, let's get started. So I'll just go to the track here. Also, I'm a Topita Plus freelance data analyst on the Upper platform. So I've had major success on the platform for the last 2, 3, 4, getting close to 5 years now. And I have a coach who has been coaching me all about freelancing and remote work. So he has the course currently on, which is a freelance client management course. I'll drop a link to the course under the YouTube description. Do check it out. You can give the course a shot. So if I start exploratory data analysis in SQL, I think I'm starting. So each in the career track, so each courses has 4 chapters. Get down. So I'm currently on the third chapter of this exploratory data analysis course in the career track right now. So I've completed chapter one, chapter two, chapter three. So I'll just download the data set, the slide here, just to follow along with the instructor. I always love the slide open in my other screen. I'll download, close, then open that in my second screen. Oh, just a minute. Translate chapter 3. And boom, we are good to go. Open with. So character data types and common. Okay, let's get started.
The next type of data we'll be exploring
Oh, let me change.
is character or text data. There are 3 types of character columns to store strings of text. Character, which can be shortened to char, character varying, which can be shortened to varchar, and text. They differ in the length of the string of text they store. The length of a string is defined as the number of characters in it. Character columns store a fixed length string. Spaces are added to the end of shorter strings to make up any difference in length. Spaces at the end of the string of character columns to store strings of text. Character, which can be shortened to char, character varying, which can be shortened to varchar, and text. They differ in the length of the string of text they store. The length of a string is defined as the number of characters in it. Character columns store a fixed length string. Spaces are added to the end of shorter strings to make up any difference in length. Spaces at the end of char fields are ignored when comparing values. Varchar columns can optionally specify a maximum string length. They allow strings of any size up to the specified maximum. Text, or varchar columns without a maximum length specified, can store strings of unlimited length. Regardless of the formal column type, For analysis, we want to distinguish between two types of text data: categorical variables and unstructured text. Categorical variables are short strings of text with values that are repeated across multiple rows. They take on a finite and manageable set of distinct values. Days of the week, product categories, and multiple choice survey question responses are all examples of categorical variables. Unstructured text consists of longer strings of unique values, such as answers to open-ended survey questions or product reviews. To analyze unstructured text, we can create new variables that extract features from the text or indicate whether the text has particular characteristics. For example, we could create binary indicator variables that denote whether the text contains keywords of particular interest. For now, we'll focus on categorical variables. The first things to check with categorical variables are the set of distinct categories and the number of observations or rows for each category. We do this with group by and count. Without ordering the results, it's hard to tell which categories are commonly used and whether any categories should be grouped together. Ordering by the count of each value helps us see the most and least frequent categories. It's good to check whether categories with only a few observations have errors, such as spelling, capitalization, or spacing mistakes. It's also a good idea to try ordering the results by the category. Doing so can help us identify possible duplicates and other errors in the data. Does the ordering of the categories in the results match what you were expecting? Character types are sorted in alphabetical order. Spaces come before letters, and uppercase letters come before lowercase letters. Looking at the first character of each category shows that the results are in alphabetical order. So what are you looking for when grouping and counting values? Common inconsistencies and issues with character data include differences in case. For example, when there are both lower and uppercase versions of the same value. White space differences, such as when values only differ in the number or placement of spaces. One exception here is that when comparing values of type char, trailing spaces are ignored. An empty string, which is a string of length 0, is not the same as a string of all spaces. An empty string is also not the same as null. These are distinct values. And finally, punctuation differences. Punctuation differences can sometimes be subtle. For example, there are multiple types of hyphens and dashes that look similar but are different characters. We'll learn how to address these inconsistencies later in this chapter, but the first step is to practice identifying them.
Okay, let's see that. It says counting the categories. In this chapter, we'll be working mostly with the Everseen 311 data in table Everseen 311. So we're working with this table here, Everseen 311. This data on help request submitted to CP or Everseen. So this data on help request submitted to the city of Everseen in the Onions area. So this data has several character columns. Starts by examining the most frequent values in some of these columns to get familiar with the common categories. How many rows does each priority level has? So we have this priority level here. Count the number of rows there. So let the count of each level of priority. Each level of priority. Okay. So from plus there. Once select priority, then the count of each level of priority. That's the count star. Then can go by priority. Let's see that. give that a shot. What's the issue there? How many rows does each priority level has? To select the count of each level of priority. This is the priority. Each level, we want to count each level of priority. This is quite straightforward now. Select priority, count star, group by priority. There's a count column there. What is the issue now? This select now. What's wrong with the network now? What's this? What's this? Select the count of each level of priority. So let's reload this page then. So select priority. Want to count each level of priority. Okay. We count star. We could say there's priority here. Then count star. So we say, oh, the best to say is to go by. Even if I run the code alone, it will return an error. Definitely an error there. You see, I have to go by priority. If I run it now, I shouldn't get an error, but it's still returning an error. Why? Okay, let's see. Let me check the columns everywhere. We only have how many columns there? Just a few columns. Straight name out and description. Select the count of each level of priority. This is the priority. You want to count each level of priority. That's really straightforward. How many rows does each priority level? Most frequent value. Okay, let's see. Okay. How many rows does each? Hmm. Imagine. That's what I did. I'm getting an error. Wow. If I'm grouping by, I can't be grouping by count star. Come on. Group by. Hmm. Group by close. Wow. Same error from the int to saying I should go by count star. Use group by and count star. Okay, that was telling me. But I can't be grouping by count star. Hmm. Go by priority. Definitely go by priority. Probably an error from the engine because this is quite straightforward. This is not fair though. Let's copy the code. Let's just show the answer. Got a silly mistake I was doing. I'm writing the code wrongly for the first time. Like for the first time, I'm writing the code wrongly. So let's reset it. Imagine. You are prone to make errors. Like now, how many distinct values of zip code appear? It says how many distinct value of zip code? How many distinct values of how many distinct values of zip code appear in at least 100 rows? Find the value of zip code appear in at least 100 rows. Also get the count of each value. Okay, count of zip codes. It says how many distinct values of zip appear in at least 100 rows. Mm, let's see. Zip. Shall we count star? Can say no. We want to give distinct counts. Let's give this a shot. But the goal is to have a distinct count. If I run that, I should get. Oh, that's quite straightforward. That's correct. So, how many distinct values of each of source appear in at least 100 rows? It's almost the same thing that we have. Also, how many what? How many distinct values of source? Let's look at the source. We use the source column here. go by source where having let's see that. So the last one says select the five most common value of street and the count of each. Streets find the five most common values of street and the count of each. Five most common value of street. Let's go. Find the five most common value of street. Priority source. What do I mean by what is street? I can't see street here. Oh, hold up, hold up. Oh, hold up. I need to attend to something real quick. Oh, okay. Okay, I'll come back to this. On solution. Okay. Be right back. Um, minutes. Hold up, hold up. I need to do something real quick. Okay, so I'm trying to beat a time frame.
Two of the most common
Hold up. Okay.
Watch out for extra spaces and case inconsistencies.
Oh, okay. I'm going back to this. Oh, okay. Hold up. Trying to check something to out. Splitting and concatenation test. Okay.
When working with text values,
Oh, hmm. The minutes strategies for multiple transformations. Okay.
you've learned several group
Clean up everyone's section data. Okay.
when statements can also be useful in other situations. Time to practice using them to clean up the Evanston 311 data.
Okay. We have the challenge here also. Okay, so let me go back to where I was earlier. I think I was there. I know all the videos in the course. Yeah, the video, then the video in this chapter, then the video. Let me go back to this beginning here. Okay, I think I was there. Why didn't limit that? I solved this one. How many distinct values? Okay, yeah, that is why I stopped. Yeah, so it says how many, come on, the database should be fired up by now. Great. It says how many distinct values of source appear in at least 100? Okay, the source there. Oh, okay, the code is not okay. Finally, it is up. So the source table here, select source. We are counting each rows from Evans 311. Then go by source, having count greater than what? So that is at least so many sources that appear in at least 100 rows. You are seeing the sources that appear in 100 rows. If I run the code, let's see that. So based on the sources here, that has 100 rows, and this one has over 100 rows. This 100 source to have more than 100 rows. Iframe, it has record of more than 100 rows. So you can see that. Let me quickly off my camera here. So it's me saying the number of sources there and how many times they appear in the table. This appeared more than 100 rows, 100 rows, more than 100 times. If I submit that, that should be correct. Then we'll move to the next challenge. This one says select the 5 most common values of streets. I'm also looking for the street column here. 5 most common value of street. Category, date created, date completed. Oh, and we have streets here. So this is street. You can come in select street, count star from go by street, order by count, descending to limit 5 most common value of street here. So funny enough today, I think I made the simplest mistake ever. I was bringing the go by clause before the from clause. Silly mistake ever that I've done to writing SQL code. Okay, that solution is quite correct. Okay, now this one is saying explore the distinct values of street column. Select each street value and the count of number of rows with that value. Select each street value. It says select each street value. Explore the distinct values of street column. The street column. Okay, let's say select. So explore the distinct value of the street column. Select each street. So select streets. Select each street value and the count of number of rows with that value. Then count of streets. That will be from this table. From this table, definitely we are grouping by since we have the count and aggregation clause there. By streets, definitely. Then it says what? Count rows with that value. Sort the result by street to see similar values near each other. Then order by street. And let's see the result of that. Let's run the code. correct. And ordering by that category. Why is the code one taking time to load? Why? Why? Mm, that says so the result by street to see similar values near each other. So I didn't even specify the sorting I want to do there. But hold up. Hmm, that's quite funny. So explore the distinct values of the street column. Select each street value. Mhm. Count the number of rows with that value. Sort the result by street to see similar values near each other. This is quite funny. Like seeing this as error. Order. Oh, look at my slay mistake. I also put order. I didn't put by. You see that I just have to read the code twice to know my error. So you can see that that's the result. And that says what which of the following is not an issue you see with the values of street. Found similar values with each other. That says what look at the results. Sort the result by street to see similar values near each other. So I didn't so if I say order by street by default is ordering it is it descending or ascending? I didn't even specify how to order it. So that says which of the following is not an issue you see with the values of street? The street of you see the street avenue is sometimes abbreviated. There are sometimes extra spaces at the beginning of and end of values. Extra spaces. You can see that how street numbers sometimes appear in the column. How street numbers. Okay. Capitalization is not consistent. Let's see. Okay. Okay. So which of the following is not an issue you see with values of street? The street surface, the street avenue is sometimes abbreviated. Yes, avenue is abbreviated. How about street? Okay, I think all of the above is the answer there. Okay, one item is it. So let's check. There are sometimes extra spaces. I'm not sure about that. Can you see the extra spaces there? All street numbers sometimes appear in this column, so you can't see the extra spaces there. That's not possible. But all street numbers, so there are street numbers there. 217A, capitalization is not consistent. So that's correct there. What's wrong? I'm just making silly mistake with my code today. I wrote order, I didn't put the by there, and that's not fair. So let's talk about cases and spaces. Let's learn cases and spaces. Well, let's reload the code page. I think we solved all that ourselves. Okay, we are good to go. Cases and spaces. Let's see that.
Two of the most common inconsistencies in text data are differences in the case of characters and in the spaces in a string. We can deal with these issues by using functions to change character case or remove spaces, and by querying data with the like operator. First, one of the easiest ways to handle inconsistencies in case is to convert character data to either be all upper or all lower case. The upper and lower functions do just that. The functions have no effect on punctuation or numbers. You can use the lower or upper function to make comparisons case insensitive. For example, the fruit data here has 8 entries corresponding to apple, but there are 6 different ways the data is entered. To select rows from the fruit table with the value apple, regardless of case, we can convert all favefruit values to lowercase with the lower function. Then select rows where the result of the function is equal to apple, all lowercase. Note that while we got both upper and lowercase versions of apple in our 5 results, we are still missing 3 values with spaces at the beginning or end of the word apple, or with the plural apples instead of apple. The like operator can help us match values of apple that might have extra spaces or s's at the end. By using a like pattern with a percentage sign before and after apple, we match favefruit entries where apple is anywhere in the string. Remember that with like, percentage matches any number of characters, including 0, while an underscore matches exactly 1 character. Now we have values of apple with spaces and s's, but only lowercase. To make this query case insensitive, we can use I-like instead of like. The I
Mm,
stands for insensitive.
okay,
I-like queries
insensitive.
take longer to run than like queries, so only use them when you need to. Using
Okay,
I-like, we also select variations of apple with uppercase characters. All 8 variations of apple are now in the result. Remember, though, that like searches can match more than you may intend. Our query to select apple values would also select pineapple. Our query to select variations of apple with uppercase characters. All 8 variations of apple are now in the result. Remember, though, that like searches can match more than you may intend. Our query to select apple values would also select pineapple. Turning now to the issue of extra spaces, one way to deal with them is to use a trim function to remove spaces from one or both ends of a string. Trim, or btrim, removes spaces from both ends of a string by default. rtrim removes spaces only from the right, or end, and ltrim removes spaces only from the left, or beginning. By default, the trim functions remove only the space character, not other whitespace characters like tabs or new lines. While the functions remove only
okay,
remove spaces only from the left or beginning. By default, the trim functions remove only the space character, not other whitespace characters like tabs or new lines.
okay,
While the functions remove spaces by default, you can specify other characters that should be removed instead. You can remove a single character, such as an exclamation point, or a set of characters altogether in a single string. The trim functions are case sensitive, so in the second example, we include both an upper and lowercase w. Instead of specifying both lower and uppercase versions of the same letter, we can combine functions. Remember that we can nest the call to one function inside another function. The inner function is executed first, then the result is sent to the outer function. Here, we first convert all of the characters to lowercase with the lower function. Then we use the trim function to remove exclamation points and lowercase w's. Now it's your turn to practice bringing order to messy text. Watch out for
okay.
extra spaces and case inconsistencies in the exercises.
Thanks for the headers. Let's have this also now. Okay, let's have this code. So it says there, select distance street. Okay, so distance street. So it has been selected for us. Select distance street. Then trim off unwanted characters from street. Let's see the street column. This is the street column. So trim. What character do you want to trim? So what are the unwanted characters that I want to trim? We'll definitely just assume it is space. So trim digits, okay. Trim digits 0, 9, hash, and spaces from the beginning and end of street. Select the distinct original street value and the corrected street value. Select distinct original street value and the corrected street value. Order the results by the original street value. Clean street, okay. Trim street, it says unwanted characters. So we want 0, 9, what are they? We want to specify what we don't want, right? So I'll just say we don't want 0 to 9. That's quite funny. So how do you specify that? 0 to 9. Hmm. Don't want hash mark. Don't want hash sign. We don't want slash. I don't want spaces. Wow. Okay, let's see. Order by clean street. Let's see the result of that. Okay. Let's see if that is correct. Probably won't be easy for us to start looking into history. Hmm. Check the first entry of the expression. So my 0 to 9 should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hmm. And dots. How about the space? Okay. Dots. We don't want dots. So my space has to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Space. So we're going to trim up 0, 1 to 0 to 9. Uh, hash mark. Hash mark. So I've left a space here and any dots there. Okay. Let's see. Aha. So I'll just remove the 0, 1 to 9 there. That's cool. Note that the cleaned values will include letters from house numbers and trim strip off some numbers that belongs to part of the code name. It can take several tries to find the right combination of functions to clean up messy values. So that's quite funny though. So this one says exploring unstructured text. So the description column of this table has the details of inquiry, while the category column groups inquiries into different categories. Let's see the description column. This is the description column here. Description has the what? Has the details of the inquiry, while the category column groups what? Groups each inquiry into different categories. How well does the category capture what is in the description? Like and inconsistent like queries will help you find relevant description and categories. Remember that the like query, remember with like queries, you can include the percentage sign on each side of the word to find values that contain the words. For example, select category from this table, where category like any words that start with any number of characters, then tax Z, and any number of characters at the end. So percentage matches 0 or more characters. Building up the query through the steps below. Find inquiries that mention trash or garbage in the description without trash or garbage being in the category. It says building up the query through the steps below. You have to find the inquiries that mention trash or garbage in the description without trash or garbage in the category. What are the most frequent categories for such inquiries? Use like to count the rows in this table where the description contains trash. Okay, use like to count rows where description contains count contains trash or garbage regardless of the case. Okay. So we want to select the description. Count rows where the description contains. We only want to count rows. Okay, we're not even returning any rows, any column along. So count star. So count the number of rows there. Where description includes trash or garbage. Where description like, okay, where description like where description like, so that should be that, like should be trash. So I don't want to any percentage, or we not say or. Oh, my where clause is 2 here. I use or, yeah, or description like description like, can I say garbage, Ga- garbage. Let's find that. I see. So let's return a number of rows for that. Oh, GLGALBAGE. What's the error there? The code. Oh, I didn't put the closing code there. I was missing one code there.